Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Alright, describe and correct the error in using the AA, the angle-angle similarity theorem. So this picture shows us that we have angle B congruent to angle F, angle C congruent to angle G. So they conclude that these two quadrilaterals must be similar because of the AA similarity theorem. Now, if we look at these quadrilaterals, we can tell they're not congruent, they're not similar, because they don't have the same shape, right? B and F and C and G might be congruent, but angle A and angle E are not congruent, and angle D is bigger than angle H. So these definitely cannot be congruent. So something has gone wrong, because these quadrilaterals cannot be congruent. What did the AA similarity theorem state, though? The AA similarity theorem is for triangles. That only have 3 angles. So if 2 of them are congruent, the third one has to be congruent. In quadrilaterals, we have 4 angles. So if just 2 of them are congruent, we have no idea about the other 2. So their error was they used a theorem for triangles on a set of quadrilaterals. And you can't do that. So if we were to correct this error, we would say there's no way of knowing. Like, we don't know if these are similar. And actually, we can tell they're not similar, right, by looking at A is not congruent to E, etc., etc. But their mistake was that they used a theorem that was for triangles on quadrilaterals. Can't do that. Okay, good. Let's move on to what we have for today. Today we're moving on to section 8.3. In section 8.2, we learned how to prove that triangles were similar using the angle-angle similarity theorem. Today, we're going to start talking about sides. Not just angles, but sides. How can we use sides to figure out if triangles are similar? So, our learning target is that you know what the SSS and SAS similarity theorems are. Can you guess what SSS and SAS stand for? Remember chapter 5? And our success criteria is that you can use the SSS and SAS similarity theorems to show that triangles are similar. So let's do a little bit of review about corresponding parts. We talked about these in the last video. We're going to talk about them again. A pair of sides or angles that have the same relative position in 2 congruent or similar figures. The definition talks about congruent figures, that corresponding angles are congruent and corresponding sides are congruent. So this is for congruent figures. But in similar figures, we still have corresponding parts in similar figures, but instead of the sides being congruent, we have proportional sides. So side AB is similar to side D, or proportional. This symbol can also mean proportional too. You'll learn more about that in higher level math classes if you choose to take them. And BC is similar to EF, etc., etc. So in congruent figures, all of the corresponding pieces are congruent. In similar figures, remember, for similar figures, angles are congruent, sides are proportional. Angles are congruent, sides are proportional for similar figures. What are similar figures again? Remember, they are geometric figures that have the exact same shape, but not necessarily the same size. So we can map them using a dilation. We can turn the green shape into the blue shape using some scale factor. In this case, the scale factor is 3. So, same shape, Could have a different size, though. All right, let's jump into the meat of the lesson, the new stuff, the side, similarity theorem. So what this theorem says is if the corresponding side lengths of two triangles are proportional, then we know that the triangles are similar. So in the last video, we knew that if two pairs of angles were congruent, then we knew that these triangles were similar. In this video, this theorem is talking about the three sides. So we need all three sides to be proportional to the same scale factor, and then the triangles are similar. Okay, great, Mrs. Dodge. I remember what proportional sides mean. I remember that from 8.1. But what does this look like in an example? I'm so glad you asked. Example 1 is either triangle DEF or triangle GHJ similar to ABC? Well, if they are similar, I don't know anything about the angles, right? I don't see any markings on the angles, so I can't use the angle-angle similarity theorem. I can only go off of the sides that I'm given. So, first, they say, are they similar to ABC? So let's look at triangle ABC and triangle DEF. Then we'll look at triangle ABC and triangle GHJ. There's two parts to this question. We want to know, is DEF similar to ABC? And is GHJ similar to ABC? So there's two parts to this question. We're going to focus on triangle DEF first. So, if these two triangles are similar, all of their sides need to be proportional. I should be able to write out a statement like this and have it be totally true. So what we're going to do, notice how they color-coded for you. They color-coded, they have red sides, green sides, and blue sides. That's nice of them. Another way that we could think about this, because maybe they won't color code on your homework, is you can think of the shortest sides go together, right? If these parts are corresponding, or if they're proportional, the shortest sides should be paired together, the longest sides should be paired together, and then the medium sides should be paired together. So you can think of it that way as well. So what we're going to do, I'm going to put triangle ABC on top and triangle DEF on the bottom, because remember, we have to stay consistent or we could mess things up. We need to look at the same ratios. If you flip them and all of a sudden triangle DEF is on the top, now we're not talking about the same proportion or the same ratio. So let's take the shortest sides, or the red sides. So I'm going to put triangle ABC on top. We have 8, 2, 6. Now, if I simplify that fraction, I can divide on the top and bottom by 2, and I get 4/3. Okay, now if I do this with the longest side, which is the blue, I have 16, because triangle ABC is on the top, 16 over 12, which, if I simplify this, I can divide by 4 on the top and bottom, and I get 4/3. Look at that. These two sides both have the same scale factor. They are equivalent fractions. 8/6 is equal to 16/12. So this is a good start. We just need the last set of sides to also be an equivalent fraction, and then we will know that all of the sides are proportional. So now we're going to look at the other sides. We're going to look at the medium sides, which are the green sides. So on top we have triangle ABC, 12 over 9, and if I divide by 3 on the top and bottom, I get 4/3. So I know I have the shortest side. The ratio of the shortest sides is equal to the ratio of the longest sides, which is equal to the ratio of the medium sides, right? They're all equal to 4/3. So, by the SSS similarity theorem, triangle ABC and DEF are similar. Are similar by the SSS similarity theorem. Okay, that's part 1 of the problem done. We need to do part 2. So let me clean up this diagram. Now we're done with triangle DEF. So I'm going to cross it out so that I don't accidentally mess it up, because now we're looking at ABC and GHJ. So, again, I'm going to put triangle ABC on top and triangle GHJ on the bottom. Have to stay consistent. If we had flipped this, we would have gotten 3/4 over here. 3/4 isn't the same as 4/3. We have to stay consistent. So, let's do the shortest side. Oops, shortest side, which is the red. And if ABC is on top, that's 8/8, which is 1. Oh, so these sides are exactly the same length. Okay, they could still be proportional, right? Similar figures have the same shape, but not necessarily the same size. They could still have the same size, and that's what a scale factor of 1 says, is that they're the same size. Okay, now let's look at the longest side. The ratio of the longest sides, the blue, we have 16/16, which is 1. Okay, so the blue sides are the same length as well. Now, you might already be able to tell that these shapes are not similar, but let's keep going. We're going to look at the middle side, which is 12/10. Wait a minute. 12/10, that's not 1. I need all of the scale factors to be the same. Like in the first part, all the scale factors were 4/3. So I knew that the sides were all proportional. But 12/10, see, if I divide by 2 on the top and bottom, we get 6/5. These are not the same. So we have 8/8 is equal to 16/6, which is not equal to 6/5. Not equal. So triangle ABC and triangle GHJ are not similar because their sides aren't proportional. 2 of their sides are proportional, but we need all 3 to be proportional in order for the triangles to be similar. So let's check and see if we were correct. They also looked at the shortest, longest, and middle sides, and they found that all the ratios are equal. All of them are equal to 4/3, so they are similar. And in the second part, they saw that the ratios were 1, 1, and 6/5. The ratios are not all equal, so they are not similar. Booyah! We were correct. Okay, let's go ahead and move on to our second example. This also uses the SSS similarity theorem, but this problem says something different. Instead of trying to decide, are these triangles similar, we're saying, find the value of x that makes them similar. What would make these 2 triangles similar to each other? Pause the video and think about it. If these 2 triangles are similar, all of their sides need to be proportional. All of their sides need to be proportional. So that would mean that AB, and we'll put triangle ABC on top and triangle DEF on the bottom. It would mean that the ratio of 4 to 12 would need to be equal to the ratio of x minus 1 over 18, which is equal to the ratio of 8 to 3x plus 1. Right? These are all the corresponding sides. We have the shortest. We have the shortest sides here. We have the longest sides here. And then we have the middle sides here. So this would need to be true. All of these things need to be equal in order for these triangles to be similar. So, how could we figure out what does x need to be? What value of x makes these equal to each other? Well, let's see. There are many different ways that you can do this. There are tons of different ways you can do this. One way, and this is a way that I see students do it before I even say anything. Some students go, oh, wait, I see this way. So I want to point this out to you. If you look, how do I get from 4 to 12? Oh, 4 times 3 is 12. So I would need x minus 1 times 3 to be equal to 18. What times 3 is equal to 18? 6. 6 times 3 is 18. That means that x minus 1 has to be 6. In order for this ratio to be equal, I have 4 times 12, or excuse me, 4 times 3 is 12, 6 times 3 is 18. So that means that x minus 1 has to be 6. And if x minus 1 is 6, then x is 7. And we can check our answer and make sure that x is 7, and I'll show you how to check your answer. But before we do that, let me show you another way. Because some folks are like, what? What on earth? What do you mean? 4 times 3 is 12, yes, and then the x and the plus 1, what? So, there's another way that we can do this. Remember our butterflies? Remember our cross multiplication from section 8.1? We can do that here as well. We can take two of the ratios, or excuse me, we can take, two of the ratios, set them equal in a proportion, and we could take 12 times x minus 1 equals 4 times 18, which is 72. And if I distribute the 12, we get 12x minus 12 equals 72. Add 12 to both sides. 12x equals 84. Divide by 12 on both sides. And we get, x equals 7. So, there are two different ways that you can figure out what x is. Now, this value of x makes these two ratios equal. It makes the red ratio and the blue ratio equal. It makes the shortest and the middle sides proportional. What about the longest side? Does x equals 7 work for this side? Well, here's what we're going to do. We're going to take these three ratios that we set equal right here, and we're going to plug x in and check and make sure that we were correct. So, 4 over 12 equals 7 minus 1 instead of x minus 1, 7 minus 1, equals 18, which equals 8 over 3 times 7 plus 1. Let's simplify. This is 4/12 equals 6 over 18, which equals 8 over 3 times 8, which is 24. All of these ratios are equal to 1/3. If I take 4/12 and I divide by 3 on the top and bottom, or excuse me, by 4. If I divide by 4 on the top and bottom, in the middle one, if I divide by 6 on the top and bottom, and the last one, if I divide by 8 on the top and bottom, all of these are equal to 1/3. If I take 4 times 3 is 12, 6 times 3 is 18, 8 times 3 is 24. All of these ratios are equal to each other, which means that x equals 7 was correct. So this was us checking our answer. We checked our answer by making sure that, yes, actually all of the ratios are equal to each other. Wonderful. Let's check and see if we were correct. 4/12 equals x minus 1 over 18. Cross multiply and simplify and solve x equals 7. And then we check. 4/12 equals 6/18. 4/12 equals 8/24. So when x equals 7, the triangles are similar. Aha! Yay! Okay. Oh, and they pointed out you can either use, so we used 4/12 equals x minus 1 over 18. We also could have used 4/12 equals 8 over 3x plus 1. We could have used this to solve for x in the beginning. We used the x minus 1 over 18. That's fine. You can use whichever one you want. You can use whichever pair you want, as long as you have triangle ABC on the top, triangle DEF on the bottom. As long as you stay consistent, you can use whichever two ratios you want. All right. We said that we were going to talk about 2 theorems today. We have talked about the side similarity theorem. Now we're going to talk about the side angle side similarity theorem, which, if you remember the side angle side congruence theorem, triangle congruence theorem from section 5.3, you will remember that when we say side angle side, we're talking about 2 sides and the included angle. Now, these aren't the markings that I want to use because these aren't congruent, they're similar. So we could maybe do a squiggly lines to say they're not congruent, they're proportional, but we want the included angle. We want the angle in between these 2 sides. So if the angle in between the 2 sides is congruent, because remember, angles are congruent, sides are proportional. So if 2 sides are proportional and the angles in between them are congruent, then the triangles are similar. Triangles are similar. So, make sure that this is in your notes. All theorems should go in your notes. And let's see this in action. Let's see an example of what this looks like. So, you are building a lean-to shelter starting from a tree branch, as shown. So, this is what a lean-to shelter looks like, and this is our shelter that we are building. Can you construct the right end so that it is similar to the left end using the angle measure and lengths shown? So what do they have shown for us? They have that angle F and angle A are both 53 degrees. This is off to a good start. Very good start. We have that angle F is congruent to angle A. So we have a pair of angles that are congruent. Now we just need to know, are the corresponding sides proportional? If they are, great. SAS similarity theorem, because this angle is in between the 2 sides. If they're not proportional, well, sides need to be proportional in order for the triangles to be similar. So what we're going to do is we're going to take, let's put triangle FGH on top, and we'll put triangle ABC on the bottom. It doesn't matter if you want to switch them around, it doesn't matter. It's whatever you want as long as you stay consistent. So, we have 6 feet, that'll go on top because it's triangle FGH. 6 feet to 9 feet, because these sides are corresponding, needs to be equal to 10 feet, because that's triangle FGH, it stays on top, to 15 feet. These need to be congruent. Now, there's two different ways that we can check and make sure these are congruent. One way is we can simplify the fractions. We can simplify 6/9, divide by 3 on top and bottom, and we get 2/3. And then if we simplify 10/15, we divide by 5 on the top and bottom, and we get 2/3. They are equal, these ratios are equal, the sides are proportional, so boom, we're done. If you're like, I hate simplifying fractions, there is another way. There is another way. I can take 6/9 equals 10/15, and you can cross multiply. 9 times 10 is 90, and that must be equal to 6 times 15, which is 90. They are equal, so the sides are proportional. The ratios are equal. So you can do it either of these two ways. I don't mind which way you do it. Both are sound mathematics. So we have the 6/9, or excuse me, not 6/9. We have 6 and 10. No, wait, okay, I'm sorry. We have the 6 feet, which is side FG, is proportional to side AB. And we have the 10 feet, which is side FH, that is proportional to side AC. So, notice we have side, angle, side. We have a pair of sides that's proportional, 2 angles that are congruent, another pair of sides that are proportional. So, yes, it says, can you construct the right end so it is similar to the left end? Yes. Triangle FGH and triangle ABC are similar by the SAS theorem. That would be our final answer. Yay! Let's check and see if we were correct. Both the measure of angle A and the measure of angle F equals 53, so angle A equals angle F. Next, compare the ratios of the sides that include A and F. They put triangle ABC on top, so they got 3/2. We did it the other way, so we got 2/3. That's okay. But the important part is that they also said, yes, you can make the right end similar to the left end of the shelter, because triangle ABC is similar to triangle FGH by the SAS similarity theorem. Yay! So, a little bit of summary. We're not going to spend too much time on this slide. Triangle similarity theorems. 3 ways you can prove or you can show that triangles are similar. You have the AA similarity theorem. 2 angles are congruent. You have the SSS similarity theorem. All 3 sides are proportional. And you have the SAS similarity theorem, where 1 pair of angles are congruent and 2 pairs of sides are proportional. So, these are 3 ways that you can prove or that you can show triangles are congruent. Or similar. Triangles are similar. Ooh! Congruence was chapter 5. So, this summary is 8.2 and 8.3 put together. Okay. That is all I have for you today. Pause and rate yourself on your understanding of the learning target and the success criteria. Do you know what the SAS and the SSS similarity theorems state? And can you use them to show triangles are similar? Are you a, yes, I most certainly can, or, I think, I kind of sort of get it, I'll need to try the homework, or are you totally lost? It's okay to be totally lost. That's part of the learning process. At some point in time, we are all totally lost. So don't feel bad if you're totally lost. Just ask your teacher for help. Ask a friend. Talk to your parents. Whatever you need to do. Alright, here are some practice problems you can do to practice the skills that you have learned in this video, and of course the different types of problems correspond to the different examples we did in this video. And as always, let's end our video with a launch, shall we? I really like this launch. It comes from Brian Herbert, and he says, "The capacity to learn is a gift. The ability to learn is a skill. The willingness to learn is a choice." The capacity to learn, the fact that we can learn, that we are capable of learning, that's a gift that all of us have. Don't think, oh, that person got more of the gift than me. No, no, no. We all have the capacity to learn, and our brains can grow. All of our brains can grow. So all of us have the capacity to learn. It is a gift given to us. The ability to learn is a skill. It's a skill that you have to practice. Being able to learn is something that you have to practice. You have to figure out your learning style, how you learn best. That is a skill that you have to hone. The willingness to learn is a choice. Whether or not you are willing to learn, if you're willing to figure out your learning style, if you're willing to try again and again, if you're willing to keep going when learning gets hard, that is all a choice. So, are you willing? Are you willing to choose to want to learn? Because it can be very easy to give up. It can be very easy to go, my head hurts, you're using big words I don't know, I'm out. I'm done. I've had those conversations with Mr. Dodge where we're trying to talk about some math thing, and I'm like, I don't know what you're saying, I'm frustrated, I want to give up. And I have to take a breath, and I have to pause, and I have to say, okay, can we pause? Let's go back to where I do understand, and let me ask some clarifying questions, and let me see, like, where I'm not understanding. Like, where is the break in my understanding? So, it can be difficult, but if you choose to be willing to sit with the discomfort, to sit in the struggle that learning sometimes is, you can learn. Everyone can learn, but the willingness to learn is a choice. So, what will you choose? That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.